A real villain?
Well, technically, nah.
Have you ever caught a good guy, like a real superhero?
Nah.
Have you ever tried a disguise?
Nah.
All right. I can see that I will have to teach you how to be villains.
Hey everybody, we haven't covered this topic at all in our AP Computer Science class. It has to do with the double equals Boolean check versus the dot equals check that is run on strings like we told you guys. We're going to get much deeper into this later, but I wanted to kind of tell you guys about the difference between integers and strings and how they act differently. So let's take a look. What would you expect to see if A is 1 and B is 1? Is it true that A is equal to B? Let's take a look down here. On the bottom, we do get that that's true. Now let's say if I set B to 0, right? Would we expect to get true or false? In all logical worlds, we would get false, and we do. Now what if I set B to be 0, and then I incremented it? Now B should be 1. Should this now be equal? Let's see. Yes, they are, because B turned out to be 1, and so is A. So let's watch how weird this is. When Java does this with strings, it's a little bit different. All right, so let's just kind of start with a string, my name. And I'm going to say my name is Brian, because indeed it is, not Brina. And my dog's name. I'm going to say that my dog's name is Brian. Okay, so this is where we can kind of run into a little bit of confusion here. Is it indeed true that my name is equal to my dog's name? Now, some people may have checked this. You guys have, some students of mine have been trying this out and are saying, hey, you know what you told us about like using dot equals to check strings for equality? Well, I tried it with something like this and I get true. See, watch, Mr. Fleischman. Look, they're true. You don't need to use dot equals. Well, here, let's look. Okay, so notice up here we have B being 0 and incremented to become 1. Let's go ahead and do this. Let's make my dog's name Brian. If I run this test, I should get false, right? Because Brian is not the same as Brian, and indeed that's true. Now, we can actually take this string, my dog's name, and add to it. Okay, so check this out. I can add the letter N to the end of the dog's name. And just to be sure, let's print my dog's name just to make sure this worked out. I print my dog's name, I get Brian, and that is the same as my name, right? So what if I checked now to see, is my dog's name the same as my name? Let's see. Is it true? No, it is not. Even though, remember, we just checked to see that my dog's name was Brian. Hold on a second. I am losing my mind here. This is not cool, is it? Let's see if we can figure this out. Oops, it's out, my bad. And now it really doesn't want to behave. So let's check this out. I'm going to grab this. I want to make sure that I'm doing this right. Are we sure? So my dog's name is there. My name will go underneath it. I am just baffled, right? This is what a lot of people are going to be running into. So I'm going to print my dog's name. I'm going to print my name. And you're telling me that those are not the same? What? Okay, so here's what's going on, okay? So when Java is dealing with strings, right? What they're doing is this variable is not actually holding this information inside the variable. This is what you call a reference to a string object, okay? So this is like a little address. Somewhere in the computer, in Java's memory, there's this string object called Brian, and my name has the instructions or the directions on how to get there. Okay, now let's kind of look at this one, right? Now my dog's name is pointing to a completely different object called Brian, right? So when I append this on here, right, I'm actually creating another new string object called Brian, right? And it's going to go ahead and add to it. And this Brian is not the same object as this Brian, right? The Brian that my dog's name is holding is not pointing to the exact same object that this variable my name is pointing to. There are two identical string objects, but they're not the same one, right? So if we look at this now and we go down here and change this to dot equals, Oops, see an object. It wants an object, and strings indeed are objects. So let's go ahead and check to see if it dot equals my name. It will compare them for identicalness. Are these two objects identical to one another? Yes, they are. Okay, so what happened in that first part then? I don't understand it, right? So can we go back here? Remember when I said that my dog's name is Brian, my name is Brian, and then I sys out printed this? Checked my name being equal to my dog's name, and we got true. Well, what can we infer from that then, right? What can we infer from my name and my dog's name? They're pointing to the exact same object. Okay, so the way we wrote it here, Java assigned my name and my dog's name. It was like this thing had a reference or an address to pointing toward a string object that contained this string of characters. My dog's name went ahead and was pointed to the exact same one. Okay, but we tricked it when we did this. Check it out. When we said Brya, that created a completely new string object, different than this one, so that when we appended it, we added the N onto it, even though it was the same, it looked the same as Brian, it was a different object. It was this one, there's a different object with an N tacked onto it, and it's not the same Brian as this one, right? So the dot equals will, anytime your program, as we get further on into the year, has objects and the objects are being manipulated, changed, morphed into different forms, dot equals is going to check to see if those objects are actually containing the same information. And you're not going to run into this issue of, if they're actually the same object or not. Okay, so that's the difference between dot equals and equals. Okay, so the double equals Boolean operator checks to see if the object is exactly the same object as the other one. The dot equals operator will check to see if any two objects are identical, and it will still even return true if the objects are the same object themselves. So probably not a full enough discussion for you guys to be totally feeling great about it. But this is where you can run into trouble if you don't use dot equals on strings. It's always just safer to use dot equals, unless you're, of course, interested in knowing whether or not those are exactly the same object in Java's memory. So again, this is a big time sneak preview. We have a whole unit dedicated to objects and reference variables and how they're different than integers and primitive types. But hopefully this kind of starts to kind of open up the conversation that you guys can explore this in the future. Leave me a comment, say hi, criticize me, make a joke, whatever. I love hearing from you guys, and I'll check in with you guys later. Take care. So welcome back to Building Pig. This is part 3. So picking up where we left off, we are in the middle of developing what it looks like for a player to take a turn. Okay, so far we have so-and-so's turn, right? And of course it doesn't have to be player 1's name. And I'm going to fix that right now. It's not necessarily only player 1's turn. It's just whatever player is in here. So let's make sure that anybody coming in to look at our program doesn't think that it's only player 1 that's going to be in here. So let's just say player name. Okay, so where we left off was we rolled a number. If the roll was 1, we want to return 0 for that turn score. Otherwise, we want to keep rolling, and then eventually what we're going to do after this while loop, if they choose to stop, is to return their turn score down here. So just to help me not forget. And this is my kind of like, stubbing it out, just make sure I don't forget to do that. So let's go ahead and put these messages in. Right, so let's kind of say something like this. Oh no. And then we'll say player name. Got nothing on this turn. Okay, so let's say now that we've assumed that they haven't rolled a 1, we want to say something similar. So I'm just going to borrow this because I hate writing system out println or even sys out, because you guys have seen me miss on that shortcut a zillion times. Okay, so let's just kind of change this to player 1 name has, and then let's say that whatever their turn score is right now. so far, right? And then it'll prompt them to roll again. So they get a 6 on their roll. It'll be like, Brian has 6 so far on this turn. Want to roll again? Yes or no? And if they say no, right? So if their choice was 2, player wants to roll will be false. The while loop will check player wants to roll. Nope, it's false. Then it'll just return turns. Actually, I could have just, this was such simple pseudocode that I could have probably just done this. There you go. And then let's actually print a message there too as well. Let's say player name cashed out with, and then the turn score, and then points. And then let's do a little bit of a line break here, because I'm just assuming that it's going to look nicer. I do this to kind of like break up the game so it doesn't look like just like a long sort of cascading mess of text. Okay. All right, so this looks pretty good for the turn score. If there's a bug in here, I'll catch it eventually. So let's go ahead and look back up. Let's just make sure this is good, okay? So it's whatever player, it's player's turn, okay? Their turn score is 0. We're going to assume they want to roll, so we enter the while loop. The random roll is determined from 1 to 6. If it's a 1, oh no, you got nothing on this turn, return 0, then it's going to be the other person's turn. Otherwise, right, if it's not a 1, then the turn score gets incremented by the whatever roll just happened. And then we want to inform that player, so far you have this many points. Would you like to keep rolling? If yes, then basically what's going to happen here is if they say 1, it's just going to go back up through the while loop. Player wants to roll, but continue to be true. Otherwise, if they say 2, we'll assume that player does not want to roll anymore. And then we say, okay, they're going to cash out. So this player, so-and-so, cashed out with this many points. And then we go back and return whatever their turn score was. This looks pretty good. I don't see anything too wrong with that. Can you imagine how nasty this would look if we threw this into here, right? We'd have like a nested while loop and it would just look really hard to understand. Okay, so now we can look up here and we saved ourselves a lot of mess by just kind of exporting this player turn. Okay, so their turn score, remember, is going to come back. And their player 1 score will be updated by that amount, so will player 2's score. Print pig results. Okay, so this is going to be almost the last one, I believe. And we're probably going to have to test this out and make sure it looks good and it works like we think it should. I don't really like it when my parameters run on that long. You're allowed to do this, by the way. A lot of people do. So let's go ahead then and print out. Okay, I'm going to do like a special, I don't know. That's kind of lame, but whatever. Actually, I really shouldn't do that. That looks ridiculous because the 8s are in there. Let's just do a bunch of asterisks. Okay, the game is over at this point. And then, so it depends. So I wanted to pass in both players' names and scores because it's possible that I want to say that player 1 won, and it's possible I want to say player 2 won, and I determined that based on their scores. Okay, so if it's the case that player 1 score, I have my if statement. If it's the case that player 1 score is greater than player 2 score, this isn't a variable, then I want to say that player 1 won. So what we're going to see here is that the behavior is that if they both got over 100, I guess the person that got further over 100 is the winner. That's okay. All right, let's just kind of worry about that later if we don't like that. So what I want to say here is player 1 won the game. Otherwise, what I want to say then is the same thing but with player 2. Okay? Player 2 name won the game. And then maybe a little goodbye message. Do we have that already? No, let's do a little one. Like it's going to be like maybe a couple of these. Okay, I'm just trying to style it so that when I push go on the game, it looks pretty good. And then in here, I'm going to say, thanks for playing, pig. If I can get it. Try to center it a little bit. Okay, so right now I think we've fleshed out everything that I've abstracted in the main loop, and now it's time to catch the bugs. Okay, I'm assuming that it all doesn't, oftentimes it doesn't go perfectly smoothly. So let's kind of try this here. So we're probably going to see that the formatting isn't great, but that's kind of normal. Hey, look at this. Okay, so far so good. Let's say I'm going to be me. The other name is going to be my daughter.
Now listen closely. Here's a little lesson in trickery. This is going down in history. If you want to be a villain number.
Hey everybody, Brian again, back again with another Java tutorial. Tonight I thought I'd look at a problem out of Building Java Programs version 3. I'm looking at problem number 8 on page 379. This is a chapter 5 problem, so you can refer to your textbook for that. And pause this video maybe if you want to try a solution before I do. Again, this is another video where I haven't rehearsed a solution yet, so you'll get to see me in live problem solving mode, in which case, I may not write the most elegant, perfect solution, and I may kind of mess up on the way, but, it's kind of cool to see other people go through that. So I'd like to model that process for everybody. So let's go ahead and read this here. We're going to write a method called random walk. I'm transcribing this from the book. That will perform the steps of a random walk, one-dimensional, which begins at 0. Each step should either increase or decrease the position by 1, determined randomly. The walk continues until a position of 3 or negative 3 is reached, at which case the max or min position is reported. Okay, so basically we're like, if I can kind of model this with the mouse, all right, we have this number line. I'm just going to kind of visualize this. I haven't really even thought about this at all yet. 1, 2, and 3. So we're kind of here, and we're going to be here and randomly kind of bouncing back and forth until, we finally reach here, at which case we will report the minimum position that we were at, which I think what I just did was right here. And if we randomly walk and end up getting down to negative 3, then I would report that 2 was my maximum position. And I probably want to print where I am after each step as well. All right, so this is going to be kind of challenging, I think, and very likely that I won't write the best solution, but it's okay. I'd love to see your comments, especially if you see something you can improve or make more readable, make more elegant. Let's go ahead and do this though. So it's going to be public static and void. I don't see anything I need to return. Let's call it random walk, like they suggest. Okay, no parameters needed. Okay, so I'm going to think about all the things I'd like to keep track of. I'm going to keep track of the current position. And it begins at 0. I'd like to keep track of the current max position. I'm going to say that's also 0, and the current min. And I'm going to print one of these two at the end, depending on if I hit the negative 3 or the 3. I'd like to keep both of them just in case. Okay. So let's see here. I want to step. Okay, so step randomly to either left or right. Okay, so now I need to create a loop, a while loop. Okay, so I'm going to step forever until I hit one of those points, right? So while the current position, if I can get a shortcut, while my current position is not equal to 3, and my current position is not equal to negative 3, then I want to continue to step. Okay, so this is pretty critical. I'm just going to keep looping through, and the loop will exit. So step randomly in here, and update. Let's see, update the max and min if needed. Anything else? I don't think I need to do anything else in that loop. At the end of it, I'll come back and fill that out in a minute. At the end of it, I would like to say if the current position reached, or if the current position, I suppose, were 3. The current position, which is where it's going to be ending, right? This is where it ends. If it's going to be 3 double equals, then I'd like to report the minimum position, right? Can you remember that little visual I did? If we hit the far right, obviously, you know, the max is 3. So it's more interesting to print the min. So I'm going to print that. Min position was, and then I'll append on the current min. Okay, let's see, just a little bit too big a text. So I'll append on the current min. Otherwise, then that means the only other condition that would get me out here is if the current position was -3. So then I want to print. So I'm just going to like basically take this exact thing, change a few things about it. Max position. So I kind of we're making sort of like an assumption here that if it's not 3 that got us out of the loop up here, then it must have been -3, right? So, oops, -3. So, you know, maybe not quite so readable, but, you know, I think it's pretty clear that if it weren't 3, that it's -3. So you could say else if it's -3. But I think I'm just going to leave it like that for the sake of time. All right, now it's time to determine the random steps. Okay, so let's use math.random, and basically I'm going to split it down the middle. Math.random goes from like 0 to 0.99, so I'm just going to split it right in the middle where it's like from 0 to 49 is one step, and from 50 to 99 is the other, right? And of course I mean from 0 to 0.49 and from 0.50 to 0.99. So I'll split the math.random into 2 categories and step either left or right from there. Okay, so every loop I would like to determine random equals a math.random. Why am I saying int? Come on, man, it's definitely not an int. I'll fix that. It's a double. Okay, so let's go ahead and say if this double is less than 0.5, that will be step to the right. So current position plus. Spelled it wrong. And otherwise, so if it's not less than 0.5, then the rest of it on the way up to 1.0 will be a minus minus here for current position. Current position minus minus. So I have a little bit more work to do inside here. Why did I say double? It's the random that I'm interested in. If the random is less than that, when I increase the current position. Otherwise, I'm going to decrease the current position. So if I increase the current position, it's possible that current max may be overcome. Okay, so if current, so inside here, I need to kind of write a different one. I need to write a sub if statement. So if right here the current position is greater than the current max, I need to update that max value. So I'm going to say current max. Hey, guess what? You have a new number now, and it's where you are right now, current position. All right, so now I've increased the position. It's possible that at that point that it is the new maximum that we've ever gotten, right? So if that's the case, if the current position is greater than the current max that we've observed, then current max now has a new value, its current position, okay? And if not, then it'll just kind of like leave and, you know, perform another step. So let's borrow this logic and do the same thing, but in the reverse way. If current position is less than current minimum, then the current minimum gets the new value of the current position. I think we're pretty good here, but I think I'd like to print the step. We already did that. We already updated min and max. So now I want to print my location. I think we're doing pretty good on time here. Hopefully this is nice and clear. Remember, questions, comments, and stuff will be promptly addressed, so please leave them for me. So let's go ahead and print. The current location is current position. All right, that should be solid. And then, okay, so we're stepping, and it will leave the loop at the right time. If what got us out was 3, it'll tell us what the minimum was. If it got out as a -3, then the max position will be printed. Okay, so let's go ahead and run this. I have 30 seconds left, so really hope I don't have any errors. So let's call this and see if I can write the call, random walk, and observe its behavior all in 20 seconds or less. Okay, let's see. Oh, that's pretty lame. It didn't really like step very randomly. There we go. That looks better. Okay, I guess that worked. Talk to you guys later. 1 second. Bye.
You have to chase a superhero on the run. Just follow my moves and sneak around. Be careful not to make a sound. No, don't touch that.
Hey, you guys. It's Mr. Fleischman. Sorry I couldn't be there with you guys today. But I want to walk you through this click button game. After you're done with your data visualizations homework, or not homework, sorry, classwork, go ahead and go to App Lab and make this thing with me. Maybe you guys are watching this as a whole class right now, and that's great. So take a second to go to your Code Studio App Lab, and let's build this game together. And I'm going to give you guys a couple extensions that you can try. And maybe you'll feel free after this one to kind of like, venture off and do your own project here. We need to get more familiar with this App Lab as we go forward because, that's going to be part of our AP performance task. So let's go ahead and design the interface then. So we're going to need our click button. Just drag this button thing over here, and you can make it bigger right here by making, and move it around, or you can actually kind of like change the height and width with these buttons. Okay, so, or these fields over here. So the idea is button 1. The text is what actually goes in it. And I'm going to kind of make that font bigger. There's all this stuff here that you can kind of, play around with. The font size right here, make it bigger. Let's kind of make it like that. That looks good. Okay. And then I think I had another, not text input, sorry. I had a text area. Okay, so you can do the same thing here with the text area. Let's say, what is it going to say? Let's say you have 10 seconds. And then, of course, you can make that bigger, smaller, set the background color. I'm going to keep it real basic because I think this video is only going to be 10 minutes at the very longest. I think you can even set the outline. That looks kind of hokey the way it is, but I'm going to let you guys style your games the way you want. So the first screen is basically just going to look like this. You actually need to add another screen too. So here's what you do. You go over to this little drop down and you have a new screen. Screen 2 is going to be where the results are displayed. Okay, so let's have a text area in screen 2. You just drag it over there. And then you're going to say, you got a score of, right? And I'm going to make this a little bigger. Hopefully you're kind of following me. And then let's have one more text area. And that's going to be where the score actually goes. This one I want to make a little bigger too. Okay, so I'm going to let you guys figure out how to kind of style this better. This is pretty nasty looking. I can align this to the center. You can do all kinds of stuff, change the font color, everything, right? You can click this and get like a whole like RGB, like color wheel, crazy thing, right? So it's kind of cool. So we have our 2 screens, screen 1 and screen 2. So screen 2 here, let's go ahead and actually, I'm going to make this font size bigger for when the score actually shows up. The score is going to show up in this box. Okay, so now we need to actually code this thing. Okay, so let's look at the code. Basically what we need to do is have a variable called var, right? And let's make the number of, it's like the click count, right? You can change this X to whatever you want to kind of help you keep track of it. var stands for variable. The click count at the beginning of the game is 0. And then do you see this little UI controls, right? We need on event, basically it means when this thing is clicked, when button 1 gets clicked, this is what I'd like to happen. I want to take this, you see this on event. So when button 1 gets clicked, I want this to happen. So what is it that we want to happen? We want the variable x to go up by 1, not x, but click count, right? So click count equals whatever the click count was before plus 1. Now, I want you to know that this doesn't actually mean that they're equal. It just means click count is going to be reassigned the value, whatever it was, plus 1. So it's not really mathematical equals. It's kind of like it's reassigning what click count is. So every time it gets clicked, it just goes up by 1. All right. So now basically all we need to do is go to this like set timeout thing. We need to kind of like make the game have a timeout, meaning like we have 10 seconds total for the game. And let's see if we can find that. It might be under control. No, yeah, it is. So control set timeout. Okay, so this is going to happen after 1,000 milliseconds, which is just only 1 second. So let's add another 0 in there. This is 10 seconds. So it's 1,000 milliseconds. So what I'd like to do once this times out is I'm going to go set the screen, which is in the yellow stuff, I believe. See if I can find it. Set screen. We're going to jump to screen 2, right? So when this thing times out, I'd like to set the screen 2, and I also need to kind of update that text box. So what text box is this, by the way? This is text area 3. So back in my code, I'm going to set the text in text area 3. Set text in text area 3. And I want that to read whatever the click count is. Okay. And I don't know if it's going to actually take the word click count. Let's see. It might not, because it wants is that going to work? I think that's going to be okay. Click count. Did I spell it the same? All right. So let's see if this works then. So before I kind of talk about how this thing works, let's actually run the game. All right. So I'm going to play real quick. Hopefully it runs out pretty soon. My finger's already getting tired. Pretty good, 59. So that did work. Okay, so you can kind of look at this code, pause the video. Just remember what's happening here is this on event means when button 1 gets clicked, all you're doing is just updating the click count. This is actually simultaneously running. This whole like 10,000 milliseconds, which is 10 seconds, is constantly counting. And then once it runs out, the stuff in the green happens. We're going to set the screen over to screen 2 and set the text area in 3 to whatever the click count ended up being. So that's pretty simple. So a couple challenges you can try is have the click button move around the screen every time you click it, right? Click me, and then it jumps to somewhere else on the screen, right? I'm going to let you try to figure out how to do that, but like it's probably going to be set position, right? Or yeah, maybe try this set position thing every time the button gets clicked, that it moves that particular button to a different place on the screen. And there's like random numbers you can pick, right? If you go to the math thing, you can pick a random number ranging from 0 to 1. So you might want to like, here, how about this one? Random number between a minimum and a maximum, right? So like you have to figure out maybe how big your screen is. Like if you go to the design, you can kind of see, do you see those numbers, X and Y? Looks like the screen has like, 320 wide, and how tall is it? 450, right? So maybe you can move that button around. Move the button around the screen every time it's clicked. Or you could make it a bit of a game where you have to like click a certain button on the screen, and there's multiple buttons and they're all moving around, right? And you have to click the green one only. And if you get a red one, if you click the red one on accident, your score starts over, right? So I just want you to take this basic template and get creative with it and try to build something that's, a little bit cooler, and just start getting used to this idea of the on event, getting used to this idea of the var, or the variable. That's just stores some information for you. Okay. And, variables can be more than just numbers. You can have them be words and all kinds of stuff like that. Okay. So this is actually this app lab. You can pretty much design some really amazing things. I've seen some people, some of my colleagues, other teachers make some really incredible apps. So don't just think it's just like for really basic, boring stuff. It can go a long, long way. And we're going to talk about what all this stuff means, and these symbols and all these crazy things. So just kind of don't worry about that yet. We're going to have a programming unit that's going to last like 2 or 3 months that we're going to get really good at programming. For now, just have some fun with it and build your confidence. And look forward to seeing you guys on Wednesday. I hope my son's still not sick. I'm going to miss you guys. I'll see you on Wednesday. All right. Take care, you guys. Talk to you soon. Okay, guys, it took me all but 5 minutes after putting my computer away and walking to my car, where it just like jumped at me the idea of what I was doing to try to fix this problem of no space at the end. It was pretty ridiculous what I was asking the program to do, and you guys probably saw it if you're sharp. So let me show you what I tried to do, and I kind of like backed out of it because it wasn't working. I'm just going to show it to you again, and we'll look at why it was such a silly idea. So what I was asking is, if I'm looking at the very last character, and notice where I'm putting it, it's a terrible place to put this. I asked, well, if you're looking at the very last character, then I want to, I'd like to add that character on to the word. Well, this is ridiculous because if the last character is not a space, then how is it even going to get in here, right? It needs to be a space to get in here. So this is the wrong place for this idea. I had the right idea, but it's the wrong place to do this check. And here's the idea. What you want to do is think, well, there's 2 ways that a word could end in this sentence. One of the ways that a word could end would be if it's a space. Okay, that triggers the end of a word. The other case, we need to put it here. It's an else if, right? The other case is if we're looking at the very last letter of the string. So string -1. Then I want to perform the end of word checks, which is basically all this stuff, but I do need to actually tack this on. I do need to add this character on and then perform the checks. And the checks are right here. Okay, so I had the right idea, just the wrong place. And I think this is going to work. So let's go ahead and see if we get, if I say like 50 or something like that. I really should get all these characters, all these words, because they're all 50 or fewer. There we go. So that's working now. I'm getting the exclamation point at the end, and it's all good. Even if I do put the space at the end, it'll still work because that other if block will catch it. So let's see if we can kind of break this in another way. What if I put a bunch of spaces at the beginning? Hey, not bad, right? I guess this, this isn't really an issue. It's still kind of it just works. What if I say like strings of 5 or fewer? This is a tough, okay, and problem is just too long. So yeah, this is good. I guess this algorithm is fine, right? So one thing I did add just now before I started the video was I trimmed the string. So notice if I take this out, pardon. If I take this out and put a bunch of spaces at the beginning, then those spaces actually count as really short words. So all of these are really teeny tiny words, right? So basically that word, the current word was is going to be, this little space, this little space is getting added on. That's where the space comes from, is that little one I appended with the current word. So there's an empty string, that's the word, and then the space gets appended on. And I don't really like the way that looks. So if we can use the trim feature. And what the trim essentially does is we say, hey, string, you are now the trimmed version of yourself. And what that's going to do, it'll take any white space before and after the string, and basically what gets put in is this. Okay, so trim is going to take care of any sort of words with spaces before or after. So this algorithm is fine, I believe. I'm thinking even if I pass, I'm trying to break it, right? I'm trying to like make it not work. If I pass in empty string, I just get nothing back, right? So I guess that's fine. If I put in like just dots, I guess I should just get some dots. If I put in dot, and then a bunch of long string of dots, I should only get the first one. I think this is pretty tight. So there you go. There's the algorithm. I wish I would have thought of that in the first video so I could have made it in one video, but there you go. I hope you watch this video. It will help your grade if you watched part 1 especially. Take care, you guys. I'll see you in the morning, and happy coding. Good luck. Hey everybody, Mr. Fleischman again. So I wanted to talk to you guys today about frat calc and checkpoint 1. So I would really like to have this done very soon. So if you're really stumped about how to do this. I'm going to go ahead and let you watch this video, and you can kind of keep up with the rest of the class, keep up with us. So Frat Calc is a rather large program with a lot of hurdles. So what we did is broke it down into 3 checkpoints. So if you look at checkpoint number 1, which we're asking you guys to turn in pretty soon, let's go take a look at it. I think it's in my viewer here. So checkpoint 1 is asking you to create a scanner, read one line of input, and that passes it into a produce answer method. Okay, so let's just read this whole thing, get an overview, and then we'll go back and build this line by line. So this produce answer method we just mentioned breaks up that line of input into 3 separate strings. One is the first operand, the second would be the operator, and then we have the second operand. So each of these strings should be stored inside variables inside produce answer. Okay, so we're breaking up a fraction problem, for example, like this: 1 2/3 plus 4 5/6, and it splits these up, okay, into 3 separate little string variables. Okay, they're going to be separated and stored as strings. Okay, the produce answer method simply right now should return the second operand. So that might not make sense to you now. That's like, okay, how is that going to help us produce the answer? So yeah, that maybe is a little bit unclear what we're going for here. Really what we're trying to get you guys to do is parse out this string into 3 pieces, and then right now just return this as your solution. Obviously this isn't going to be what the answer is of the math problem, but that's what we're asking for right now. So that when we go to checkpoint 2 and 3, we can build upon what you've done inside this method. Okay, so let's go ahead and do that. So make sure you're in your Frat Calc class that you downloaded from Canvas. And this is what we're going to do first. Do you remember it said we need a scanner? Okay, so let's go ahead and build a scanner right here then. And then it says to take in some kind of problem, right? So I can now kind of prompt the user. Enter a problem, my fraction problem. And remember, we're not actually finding the answer right now. Okay, all we're doing is kind of taking the time to split it up. Let's just go ahead and pass in then the user's response to that. So, so this itself is a string. We could simply call the method on this string right here. But what we want to do is, I'm trying to make it readable for you guys. So what do I mean by that? So let's see, let's give you prompt. It's actually produce answer, right? So let's produce answer on the user's string or the user's response. Okay, we actually could have taken this whole scanner next line and put it in here and then just done away with this whole string user response. But this looks clear to me. So inside produce answer, we need to do some work, okay? So let's do the work with the input string. So inside here, it's called input. You'll notice that this curly brace is kind of in an unfamiliar place. I think Java conventions have it up here. So I'm going to do that. Okay, so what are we going to do with this input? Well, there's one really fast way to split this into 3 pieces. And that would be to make another scanner in here that just splits up the 3 strings. Okay, so I'm going to show you that real quick. Or since this has a local scope, I can also call it S. I don't have to though. So this, actually what this scanner is going to take, normally we write system in as sort of like an automatic, but this time the scanner isn't going to scan through anything that the user types again. We already have that input. So what we can do is have it take a look at input. Okay, so now instead of scanning whatever the user types, we already have that input and we're just going to scan through it. Okay, so I can make a string called operand 1, and I can just say that it's the scanner's next item. I can make a string called operand 2. Actually, the next is going to be the operator, isn't it? It's going to be the scanner's next item after the one it was before. And then finally, a string called operand 2 that takes the scanner's next. So what does the scanner define as something that's next? Well, it simply looks for a space. That's what it thinks the separates words from each other. Or if there is no space, it'll just go to the end of the string and it'll consider that the end of that little section. Okay, so now I'm just going to return operand 2 right now. So let's see if this works. I wonder if I print this, the result of this. I wonder if this works. Let's find out. So it's going to ask me to go ahead and enter a fraction problem, I believe. There it goes. Enter a fraction problem. About 3/4 plus 9 halves. Okay, and it prints 9 halves. It's really that easy. So some of you guys were running some pretty complex algorithms in here, and you guys were kind of looking through the string right here and trying to find spaces. What I'm going to do is, for those of you who didn't do it like this, I'm going to go ahead and do a video about how to manually take the next. Like the scanner really makes our life easy, doesn't it? But if you did it manually and you want to keep that because you're proud of it, I'm going to go ahead and do one that's kind of very similar to what you probably did. Or if you're working on that and you're stuck, maybe my video will help you through that. So just to kind of check to make sure this works, let's make sure that this returns the operand. I'm just going to look at each of the pieces and make sure it gets them all correct. Okay, so enter a fraction problem. How about 3 4/5 minus 9 8/7? Okay, so if I'm looking for the operator this time, it should give me back, it should give me back the minus sign, and it does. Let's return operand 1 and make sure it works as well. I'm sure it does, but I just want to kind of make sure. How about 3/8 times 9? I should get 3/8 come back, and I do. So the scanner is so helpful. Okay, I hope you guys seen that. I don't know if we've actually gone over a whole lot of these examples of using strings inside the argument for scanner. We've used system in here so much that maybe we're ready to explore what other things the scanner can do. And look at how fast that is. So all the logic that you guys are probably working on writing to find each of the pieces of that input string are done by scanner. So that's one clean and easy way to separate the 3 arguments out. And there we go. We have operand 1, we have the operator, and the operand 2. Okay, pretty sweet, right? Okay, so I highly recommend kind of getting used to this, because you can see what we want to do with, say, operand 1. Maybe we want to parse this out, right? So it might be useful to have a scanner looking through here. So I'm going to, obviously, throughout the whole frac calc process, I'll be posting videos about how to do this with scanners to parse and how to do the parsing manually, because I think both approaches are valuable. Anyway, I hope you guys enjoyed this video. Please look for the other video in which I'm going to show you how to manually parse the string. I think that one probably you get a little bit more content knowledge out of. This one is really cool and clean and shows you the marvel of scanner. All right, I'll see you guys in a few minutes. Check out video number 2 for how to parse input manually. Talk to you soon.
Now look at this net that I just found. When I say go, be ready to throw. Go! Throw it at him, not me! Oh, let's try something else. Now watch and learn. Here's the deal. You slip and slide from this banana peel. What are you doing?
Hey everybody, it's Brian again, back with the Java tutorial. Today we're going to be talking about the data structure array. Java has this awesome feature that it can collect items of the same data type together in one group, and can be extremely useful for a lot of different applications. So let's go ahead and just kind of take a look at a concrete example. Now before you get started, I want to see you guys go ahead and import java.util.arrays. We're going to be using this pretty soon. So there's some methods inside this class that we're going to use throughout this unit, and today we're just going to use one of them. But so here I have a list of 4 friends. Now, right now in Java's memory, each of these strings is kind of separate, standalone. So if we wanted to kind of do something with all of the friends, we would have to kind of work hard and actually access each one of them individually. So let's talk about how to collect them all in one place inside of an array. Now, what an array would look like would be like this. It would be, if I can imagine it, it would be something like this. So then I could do something with all of the friends, I could kind of collect them all together. So let's go ahead and do that. So one way we can do this, one way to make an array would be like this. So here's the syntax for it, okay? So first you're gonna start with the data type like usual. We need to make the string array, and here's how you do it. You do 2 square brackets like this. Okay, do you see how I kind of did that up here? This tells Java that you want a string array or an array of strings. And let's name it. Okay, I'm going to name this one My Friends. One way to initialize this is inside curly braces. You would just list the 4 strings, or what. You don't have to have just 4, but for this example, let's have 4. List the 4 strings that you want. Now I could either put their variables in here. I could put friend 1, friend 2, friend 3, and friend 4. Or I could put in string literals as well. I could just put in literally the Jeff in quotations and Jared in quotations. So it's up to you how to do that. Okay, so now my friends are all collected together. Okay, so this array called My Friends exists. Let's try to print it. So if the first time you've ever tried to print these, you probably saw something like this. Let's take a look. If I go ahead and run this, look in my output box. Ooh, that's weird. That's what I made. Okay. There's a really good reason we see this, and this is why. My Friends variable actually isn't containing the array where it is. The My Friends variable is an address for how to find the Java's memory spot that contains the array. So I'll just say that one more time because I kind of convoluted it. My Friends isn't holding the array. My Friends is holding the address to get to the array. So you can kind of think of this output down here as the address for how to find the array. What if you want to actually see the array itself? Well, this is why we needed to import this class, because the arrays class has a method inside of it called toString that takes an argument that's an array. So you can just put this in here. So arrays.toString, and then inside the argument you pass in the array that you'd like to print. Now take a look. There we go. That's a little better. So remember, if anytime you want to see the array that you're making, use arrays.toString. All right, so there we go. So let's talk about another way to make an array. Okay, so let's do another array called My Hobbies. So let's say we don't know how many hobbies we want, or we don't know exactly what the hobbies are that we want to put in, but we know we want 3 of them. So what you do is you say it's a string array called My Hobbies, and it's going to be a new string array, right? But inside here we say how many we're going to fill it with. How about 3? Okay. Now just remember, this is just another way. This isn't, in addition to before. This is a brand new way to do it. So this is especially useful when you don't know what you want to put in right away. So now we have this array called My Hobbies. Now let's say we try to print this out. Remember, we have to use arrays.toString, and let's put in My Hobbies. Now remember, we haven't actually filled any of the spots yet, so we're going to still see the friends array there. And then look at this. It says null, null, null. So if you're going to have a string array and you ask Java to make one with 3 spots and you haven't filled them yet, Java will fill it with something called null, which basically means, remember when we were talking about how My Friends contains an address to find the array? Well, each string is kind of like that too. Each string is actually an address for how to find a string. Now, what if we don't actually have an address? It'll just say null. Okay, so we'll talk more about null later, but you can think of it as the default value for variables that contain addresses or references. Okay, so null means I'm waiting for you to give me an address. I don't have an address yet. So let's go ahead and fill these then before we print it. So here's how you assign or even access certain positions inside the array. Now, just like strings, arrays have indexes. So we can see that in the friends array, Jeff is at index 0, Jared's at index 1, Tim's at index 2, Phil's at index 3. So let's look at my hobbies. Let's say we want to fill the 0th index, and here's how we'd say it. We'd say my hobbies at index 0 will be guitar. Okay, so now if we print this, we're going to get guitar at that first spot, right? And we still have null here because we haven't assigned those. Okay, let's go ahead and add a couple more hobbies. Okay, there we go. So now we have all 3 indexes filled. Let's talk about how maybe the array structure is really useful for looping. Okay, so after we print this, maybe we can be making a loop. So let's say we wanted to loop through an array. Okay, much like we'd want to loop through a string. We're going to begin at the 0th index, and I is going to climb to be as big as the array is. Okay, so let's talk about how to talk about the length of an array. So let's do it with my hobbies. Now remember with strings, we would say dot length, and then we'd put the curlies after it, or the parentheses. Well, arrays are a little bit different in that the length is not a method like it is with strings. The length is just a property, so it does not need the parentheses. Okay, so let's see if we can get used to that over the next couple weeks. When you're talking about the length of the array, you leave off the parentheses because it's actually not a method like it is with strings. I know it's kind of tough to remember, but we can get used to it. So let's print out kind of something silly like, so let's access the my hobbies array at index I. So how do we do that? We'd say my hobbies, whatever index we are in the loop. So it's going to begin at 0 and go to 1 and then go to 2. And then let's say like is fun. Okay, so we should get when the first time this loop executes, I will be 0. So what's at the 0th spot in my hobbies? Well, it'll be guitar. So you could say guitar is fun. I will get incremented to 1, and we'll come through here and it should say swimming is fun, and then finally mountaineering is fun, and we get that. So arrays are really useful for looping as well. So we can see how already there's already a benefit to arrays. So far we've only talked about string arrays, and we've talked about what happens when you don't fill indexes in a string array. We get that null word. So in the next video, I'm going to talk about how Java deals with arrays of primitive types, such as ints and chars and things like that. So come back for video number 2. This is the introduction to arrays, and we're going to explore how Java deals with arrays and how they're maybe a little bit different than other data types that we've studied so far. So go ahead and rewind, pause, take a look at the syntax, practice this in your own Eclipse program, and enjoy. I'll see you guys in video 2 in a few minutes. Happy coding. Hey everybody, it's Brian again. Today I wanted to introduce to you guys a challenge for those of you who are looking for something to do, something a little extra, something a little bigger. Some of you may have played this game as children. It's called Mother May I. The way Mother May I works is as follows, okay? So let's read these instructions and I'll try to explain them as I go if they don't seem adequate. So Mother May I is a 2 or more player game in which players will ask Mother if they're allowed to take a certain number of steps toward the finish line. Before each player asks, Mother, who's the computer, will make up her mind about the largest number of steps she will allow between 1 and 10 inclusive. So for example, before player 1 asks how many, so player 1 may ask, for example, Mother, may I take 7 steps? So before player 1 even asks, Mother will decide if she will allow, for example, up to 6 steps, and this number is randomly decided. So therefore, player 1 asks if he may take 8 steps. Mother will say no, and it's the next player's turn. And then Mother will choose a new random max for that next player. So the first player to the finish line wins, and the finish line is 50 total steps. Okay, so basically the idea is this. Let's see if I can explain it another way, right? So the way the turn will go is, let's say I am Mother, which is the computer, and I'm going to decide I'll allow anything up to 4 steps. And then player 1 asks me, Mother, may I take 3 steps? I'll say, yes, you may, and then that person would get 3 steps. If they would have guessed anything more than 4, then I would have said no, and it's the next person's turn. Next person's turn, I choose a new maximum, right? So then after that, it's going to be, up to that max number, all right? So there's a new maximum randomly decided between each turn. And it's kind of, if you're playing with an actual person, you can kind of rig the game. But since the computer is going to randomly decide, it is not going to be unfair. Okay, so let's see what the rest of the instructions say. Write a program that allows you to have up to 8 players. Okay, so there's going to be some input at the beginning, like how many players are playing. These players will be simply called player 1, player 2, etc. So that mother, who's the computer, will randomly choose the maximum number of steps she will allow for that player. Allow each player to input the number of steps they are going to ask mother if they can take. Mother will then say yes or no, or yes you may, or no you may not, depending on if that number is above or below or above mother's randomly decided max. After each player's turn, this is kind of a tough part. This is kind of the fun part. After each player's turn, display a graphical representation of all players and their positions in relation to the finish line like so. Okay? So then you can kind of see after every turn, this is going to be updated. So each dash is 1 step. So that's 1 step, 2, 3, 4, 5, 6, 7, 8, 9. So player 1 has moved 9 spots. Okay. This finish line, the way it works is that I'll just kind of give you a hint right here. This finish line should not be at 50, actually, because what you want to do is so that when player 1 gets to 50, the 1 is touching the finish line. So really you need to have enough room for 50 dashes and then 2 more for the P1 or P2 or whatever P you're talking about. Okay, so this little line over here is going to be 52 spaces away, 52 spaces from the beginning. Okay, just to make a room for player 1. So when player 1 is finished, essentially player 1 is going to look like, let's see if I can do this without screwing up all the formatting. Player 1 is going to look like this when they're finished. So right about, I think I went a little too far. So this is player 1 being finished. Now, I don't know if you go and count these, if that's 50 or not, but it should be, okay? I think right now it's probably not, but make sure that this is what it looks like when player 1 is finished, okay? So then after, someone finally finishes, go ahead and display a closing game screen, okay? So kind of a fun project, actually, and you're going to be using some loops, you're going to be using some while loops and some for loops, especially for, printing the graphical representation. You're going to need to make decisions about, how many players that you're going to do and how, what the graphical representation is going to look like. You may find some use for arrays that I can't think of right now, but you may want to use some arrays. So see if you can do this. Remember, practice those abstraction ideas that we went over in the rock, paper, scissors video and in the pig video. I think those are going to come in handy. So good luck with Mother May I think it's really fun, and it's actually, if you finish it, it's actually pretty fun to play with several people. It's actually to see, especially with this graphical representation, it kind of helps. It looks like a race, so it's kind of fun. Good luck. Please message me if you want some hints or leave a comment. Hope you have fun with it, and then keep an eye out in the next couple hours or days for some solution-based videos on this. And don't peek if you don't want to, right? Only go to those solutions when you think you're done or if you're really, really stumped. Anyways, you guys, hope you enjoy this challenge. I'll talk to you soon. Happy coding. Hey everybody, Brian Fleischman here for Shorewood High School AP Computer Science. These problems that we did in the last unit are still kind of biting people a little bit. I thought I'd go over it for you guys and for anybody else out there in your AP Computer Science class running nested for loops to produce particular output. Let's look at this one. This one's a classic example here. We need to use nested for loops to produce an output that looks like this. So what I recommend is creating a table on some scratch paper or anything else. And we're going to start our rows just like usual. We're going to start on row number 0 and go up from there. And we only need, I probably could do one more row here since there really is an extra row. See if I can do that really quick. Add row below. There you go. So the strategy here is we're going to need to come up with some algebraic representations of these columns and how they relate to the row number. So we're going to have to use a little bit of Algebra 1 skills in order to get this done, and it's going to be really helpful. Okay, so let's just kind of like, before we get into the table, let's go over into our IDE and kind of talk about what we want to do here. Let's see if we can remember how many, let's see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 ones, 7 threes, 5 fives, 3 sevens, and a 9. Okay, so we're definitely going to need a nested for loop for this. So let's go ahead and set this up. So we're going to need to print a row. So I recommend just kind of naming your variables by what they are. We're going to be counting rows. So some people, your teachers are probably going to say, call it I and call the inner one J. Maybe this will help by being a little more descriptive with our variable names. So the very first row we want to consider is row 0. And we want to go for as long as row is, how many rows do we have? Let's go back. We have 1, 2, 3, 4, 5 rows. So it's as easy as that. If you start on row 0, you can just go ahead and say row is less than 5. That means row will start at 0, be 1, 2, 3, and 4. And if you count, that's actually 5 different rows that we're going to get. At the end of every row, we want the row count to go up by 1. Okay, so in here, let's just write some pseudocode. This is really going to help you if you're struggling. So what we want to do is we want to print some digits. And at the end of printing the digits, we would like to skip a line or go down to the next line. It just is a little confidence builder. How do we go to the next line? That's as easy as a system out println statement. For those of you who don't know that shortcut in Eclipse, you can write sys out and then hit control space, and it'll just assume this is what you want. So printing the digits is going to be the hard part. So far we know we're going to print 5 rows. Within this loop, we're going to print some digits, and then we're going to go on to the next line. Okay, so this is what's going to really help us. The table structure is really going to help us for this inner for loop. Okay, let's go back and go to the pages here, and we'll look at the number of digits. So the number of digits is really how many ones get printed. There are 9 ones, there are 7 threes, 5 fives, 3 sevens, and 1 9. Okay, so the digit to print being this should be a 1, this will be a 3, this will be a 5, a 7, and a 9. So what we'd like to do is that the number of digits and the digit to print each have a relationship to the number of rows, right? So let's add one more row here. Let's see, add a row below. So let's make a variable down here, call it row, because that's what we used on the outside of our for loop. Now, what do you notice about the row number and the number of digits? All right, let's see if we can kind of figure out a mathematical relationship between these two. Oh, this is interesting. All right, so if you use your Algebra 1 skills here, you can see that as row increases by 1, the number of digits decreases by 2. It's like a slope, right? Remember from Algebra 1, the slope is down 2 over 1. So it has something to do with -2 times the row. So try to get the slope. It's a lot like, calculating a line based on a table, getting an equation based off of a table in Algebra 1. I can see the slope. It's a -2 slope. Now let's see if we can kind of figure this out, the rest of it by our mind here. If we do -2 times row 0, what do we need to get up to 9? Yeah, we need to add 9. Let's see if this works for the rest of them. If we do -2 times 1, that gives me -2. If I add 9, do I get to the correct number of digits? Yeah, -2 plus 9, that is 7. Let's check one more. 2 times -2, that's -4. If I add 9, do I get to 5? Yes, I do. So this is the correct expression for the number of digits as it relates to what row they're on. How about over here? This one's going to be more straightforward. What's the slope? As the row goes, let's see, this goes up by 2, and this goes up by 1. So it's a 2 over 1 slope. So it's simply a 2 slope. So 2 times row. Now let's see, it's not going to be that simple. Is it 2 times 0? Does that give me 1? No, that gives me 0. So I need to add to this. Oops, I'm going to go ahead and remind me later. I need to add 1. Okay, so is it true that 2 times 2 plus 1 gives me 5? Yes, it does. So what these become now are expressions we're going to use in the inner loop. Okay, so let's go back to our Eclipse program. This is going to help us. So to print some digits, we're going to say for the digit, the first digit printed is digit number 0, right? Not actually what we print, what digit number it is in that row, right? So it's going to be the 0th digit in the row. And we want the digits to grow to be as big as, we did all this work already. We want the digits to grow to be as big as the expression that we came up with here. -2 times rho plus 9. That is how big we want it to grow. So remember, it just depends on what row we're on, right? So depending on what row we're on, that's going to change, right? It's going to give us the correct number of digits. So we did all that math. This will print the correct number of digits depending on what row we're in. And the digit to print now, system.out.print. And here's what we're going to do. The digit to print, depending on what row we're in, we did this work. We want, we want to grab 2 times rho plus 1, right? So again, right, in row number 0, we're going to do 2 times 0 plus 1. The digit to print will be 1. In row number 1, 2 times 1 is 2 plus 1 is 3. Good, so that's going to print the correct digit if we put that in here, right? And then the next line is taken care of. So remember, if you can relate everything back to the row, you can get the correct number of digits to print, and you can print the correct digit itself. So make a little table. It'll really help you figure out what goes in here for your arguments based on what number of row you're in, right? So let's go ahead and run this, and hopefully it works. I think I'm going to be required to save. The console is kind of down here. And there we go. We get 9 1s, 7 3s, 5 5s, 3 7s, and a 9. There you go. I hope you guys found this helpful. Making a table is going to really help you get these problems right, and you're going to ace your computer science test. Please leave me some comments and some feedback if I can go over this again, or if you have any other questions you'd like me to try with you guys. Again, appreciate your time.